To work here. Here we go. So, just for a little bit, I'm going to talk to you guys about chemical and physical properties of matter. So, you guys just finished a couple days of math. Get a little bit of a break from that. We're going to get down to talking about the science of physical systems, which is describing the universe around us and how the universe works. So, we talked about physical properties of matter. We talked about mass, volume, time, were the basic properties of physical properties of matter, and we talked about derived matters like volume, speed, and density. We're gonna talk a little bit more general today about properties of matter. So before I talk about the difference between physical and chemical, let me just kind of talk. Just using some objects around here. I'm in my bedroom right now, and well, I got a pillow. So I can say a lot of things about my pillow. I can say it has some stripes, red, gray, and black. It's pretty fluffy. It's room temperature. Been in this room all day, probably 70 degrees Fahrenheit. I know that if I take a match to it, I could light it on fire. I know I could also open it and find some sort of organic material, maybe cotton or I guess polyester isn't organic, but um, you know. So lots of things that I could say. Oh, and maybe it's like about half a foot wide and 2 feet long. So again, lots of things I could say about this pillow. But what does this all mean? What does it have to do with this class, with physical systems, chemical and physical properties of matter? So chemical and physical properties of matter is how we talk about things. Um, So in this class, we're going to be dealing a lot with the physical properties of matter. If you ever take chemical systems, you'll probably be taking about the chemical properties. So let's take a look at what those two things mean and how they're related to, why we care about them. So starting with physical properties, physical property of matter is something that can be observed or measured without changing the matter's identity. And some examples of physical properties are things like color, odor, there's how they smell, their mass. Remember we said how mass is like how much stuff there is, their volume, how much space it takes up, magnetism, ability to conduct current, strength, flexibility. These are all physical properties. So these things describe, and I can change a lot of these things without actually changing what something actually is. An example that they give is, will my books fit into my backpack? When I talk about my books in my backpack like that, I'm talking about their volume, how much space they take up. When I talked about how long my pillow was, it was about 2 feet long. That is a physical property. So let's talk more about physical properties. So here's some more examples of what physical properties are. Thermal conductivity, that's how fast something can transfer heat. What state of matter is it? Is it something a solid, liquid, or gas? My pillow is a solid. I have some water here. My water is a liquid. There's a plug for SSM Health. Gas. We're breathing in air right now. So what the state of matter is, what state of matter it is, that's a physical property. Density is a physical property. We talked about density last time in this class. Solubility is the ability of something to dissolve on another substance. So when we dissolve like salt or Kool-Aid into water, that sounds like it would be a chemical property, but that's actually just a physical property. Because remember, for something to be a chemical property, you would be having to change what something is. When you dissolve salt into water, you make salt water, but I could still reverse that and still get salt and water. Anyway, more on that later. Ductility is how much I can, it's kind of like how much I can bend something. For example, a paper clip is much more ductile than a nail would be. It's much easier to bend a paper clip than a nail. Malleability is the ability to roll or pound something into thin sheets. So, and here's some more examples. A piece of silver is pounded and molded into a heart-shaped pendant. So the silver is still silver. I'm not changing anything, so that's a physical change. Another example of a physical change is changing a liquid into a solid. So if I have ice and I melt that, or I'm sorry, if I have water and I freeze that, that's changing something from a liquid to a solid. So I'm changing the temperature to change what phase of matter it's in. So on today's agenda, you'll see that you have a chart that I attached that tells you about the main phases of matter. Um, that's a physical change. Crushing aluminum can, again, I'm not changing what the aluminum is, I'm just changing the shape or the size. Sawdust, so grinding wood down into dust, well, it's still wood, so it's just a physical change. So let's contrast that with chemical properties. Chemical properties describe matter based on its ability to change into new matter that has different properties. The example they give is burning wood. So when you burn something, that is actually a chemical reaction. When you burn anything, you are changing the chemical from one chemical to another. So wood is made of tons of different organic chemicals. And when you set fire to wood, you are actually combining the wood with the air around it, and you change a lot of things, and you're changing that wood into a different chemical. I said earlier, I could set fire to this pillow if I want to. When I set fire to this pillow, it might start as polyester or cotton or whatever the heck is in here, but when I burn it, it will turn into some kind of ash. That ash has different chemical properties than the original pillow was. This right now, this pillow is nice and fluffy, can support my head. But if I burn it and turn it into ash, well, it won't be fluffy anymore, and it can't support my head anymore. So by changing the chemicals, I also change the physical properties. Um, but so burning things is an example of how I can change something chemically. Um, so here's some examples of chemical properties. The flammability is one chemical property. The reactivity is the ability of two or more substances to combine to form one or new substances. For example, oxygen is a very reactive chemical. Um, if you think of combining, like a good kitchen example is when you combine baking soda and vinegar, that is a chemical reaction. I mentioned earlier that combining salt and water is just a physical reaction, but uh, when you combine baking soda and vinegar, they're actually combining to release a carbon dioxide gas and leave behind other chemicals that was vinegar. So that is a chemical reaction. There's lots of chemical reactions that go on in the kitchen. Um, can't have kind of time to go over them right now. Um, so here's some examples here. A nail will bend. Is that a physical property or a chemical property? Well, that's just a physical property because we're just changing its shape. We're not changing the chemical. Now, if you rust a nail, if you leave it outside for too long, expose it to the elements, it will rust. You're actually that's actually a chemical reaction. If you ever have tried to work with a rusty tool compared to a tool that's not rusted, it's a little bit different. When it's a metal rust, it's brittle. It doesn't stay together that well. If you ever tried to take a rusty nail out of a board, it's not fun. So when iron rusts, it actually turns into a new chemical called iron oxide. So that's a chemical reaction. Alcohol evaporating, that's a physical change of state. By changing liquid alcohol into alcohol vapor, I'm not changing, it's still alcohol, so it's just a physical change. Now, if I burn alcohol, that's a chemical change because, again, any kind of burning is a chemical change because you're actually changing alcohol from one thing to another. It's no longer alcohol. So how do I know that a chemical change is taking place? So a lot of the times, if you change something chemically, its physical properties change. So there will be a change of odor. Ash smells different than the wood that it once was, right? Color. If the vinegar and baking soda might not be the same color that it was. Heat will either be absorbed or released, which can happen with physical reactions, but it's much more noticeable with chemical reactions. There may be a buzz or a fizz or a light or a sound may even be given off. Um, so some examples of chemical reactions: soured milk. When milk goes bad, it's actually a different chemical than what you started with. Alka-Seltzer tablets fizzing, a car rusting, the cars are changing colors. Lots of chemical reactions that go on in your body. And I do really wish that I had a biologist right next to me to give you some examples of what those are. Can chemical and physical changes be reversed? Physical changes are easily reversed. For example, you can melt ice and then freeze it again. You can start with an ice cube, melt it, evaporate it, and you can, if you catch all the water vapor, you can condense it back into water and then refreeze it. Chemical changes can be reversed, but not as easily. For example, when a firework explodes, that's a chemical reaction of magnesium, and it's hard to reverse something like that. Even vinegar and baking soda. The reason that vinegar and baking soda react so readily is because they're ready to become different chemicals. And so, but those chemicals that they make don't like to react so much. Same with when you burn anything. After you burned ash, you can't make that ash back into wood again. So chemical changes can be reversed, but not as easily as most physical changes. Okay, so I hope that helps you guys out with the idea of chemical and physical properties. The assignment that you guys have today is to just look around your house and find something. It could be any object, and then describe one physical property and then one chemical property of that object. For example, I used my pillow at the beginning of this video. So I said my pillow, I gave you the rough dimensions of it. And then I said, well, it's flammable. So pick 5 objects. Give me like a quick diagram of each object. Don't expect works that are going to be in the St. Louis Museum of Art. Just give me a sketch, then give me 2 properties of the object. So and try to change things up. Don't give me the same. It's like this object is 70 degrees, this object is 65 degrees. So don't give me temperature every time. Don't give me size every time. Don't tell me whether it's flammable or not every time. But identify at least. So take 5 objects from your home. Give me 1 physical property and 1 chemical property. I want you to try that out today. And if you have any questions, you can always get a hold of me, and I'll see you guys in class.